Alright, Chapter 4, Gas Cutting. The common method for cutting metal over the oxy-flame cutting, arc carbon arc cutting, and plasma arc cutting. Methods used depending on the type of the metal is because available equipment as with Steelworker, oxy, gas, air, carbon, arc equipment. The most common type of equipment available to use, air, works, acetylene. Oxy gas equipment is explained in chapter air. In this chapter, air, carbon, arc cutting is covered in chapter 7. Oxygen cutting torch has been used with steelworkers, named with the activities of the steelworker, found with the cutting torch, excellent, 2 with the cutting ferrous material, with the versatile tool used to operations such as bevel plate, cutting, beveling pipe, piercing holes in steel plate, cutting wire rope. When using oxygen cutting process, keep the special spot with the metal to the kindling ignition temperature for 1400 1600 degrees for steels. The term for oxy gas flame cutting a preheating flame next to the directed jet air, pure oxygen heated metal with a pressing lever on the cutting towards the oxygen cover. The chemical reaction known as oxidation take place rapidly. When the oxidation occurs rapidly, it's called combustion or burning. When it occurs slowly, it's known as rusting. When using the oxygen cutting torch method to the cut metal with the oxidation metal with extremely rapid part of the metal actually burns. The heat liberated by the burning of the iron and steel melts the iron oxide form of the chemical reaction accelerates the preheating of the object you are cutting. The molten material runs off slag, exposing more iron and steel with the oxygen jet. Oxygen gas only with a portion of the metal direct path of the oxygen jet is oxidized with the narrow slit form of the metal cutting progress called the curve. The most material removed from the curve is the form of oxides produced by the oxygen reaction. Many of the material is molten metal with the blown washed out of the curve by the force of the oxygen jet. The walls of the curve formed with the oxygen gas cutting of the ferrous metals show to be fairly smooth with the parallel to each other. Developing your skill with the handling the torch and keep the cut with the close tolerance of the guide with the cutting along a straight, curved, or irregular lines. Or cut bevel to other shape of the required holding with the torch at an angle. Partial oxidation metal is a vital part of the oxygen cutting process because of the metals that do not oxidize readily with the non-suitable for the oxygen gas cutting. Carbon steels are easily cut by oxy gas process, but there are special techniques described later in the chapter required for cutting of many other metals. Oxy gas cutting equipment. The oxy gas cutting outfit consists of the cylinder, acetylene, or MAP gas cylinder of oxygen, 2 regulators, 2 lengths of the hose fittings, and a cutting torch of the tips. Oxygen cutting outfit is referred to as a cutting rig. In addition, with the basic equipment that I mentioned above, the dormant type of the auxiliary equipment used in the oxygen cutting, an important item of the spark igniter is the term used to light the torch of the figure 4.2 view A. Another item used the apparatus wrench in similar designs is one shown figure 4.2 view B. Apparatus wrench is sometimes called a gang wrench because it fits all connection with the cutting rig. Note that the wrench system shown in the raised opening handle serve the acetylene tank key. Other common accessories include tips, cleaners, cylinder trucks, clamps, holding jigs, personal safety apparel such as goggles, hand shields, gloves, leather, apron, sleeves, leggings, and essential shoulder to be worn required for the job handling. Information on safety apparel contained in chapter 3 of the text. Oxy gas cutting equipment, stationary or portable oxy gas outfits such as the one shown in figure 4.3 is advantage when it is necessary to move the equipment from one job to another. To conduct the cutting requirements, you must be able to set up the cutting equipment and make the required adjustments you need to perform the cutting operation. For the reason important, you understand the purpose and function of the basic piece of the equipment and making of the cutting outfit. But before we're discussing the equipment, let's look at the gases most often used for the cutting, acetylene, MAP gas, and oxygen. Alright, show this, the oxygen regulator, the oxygen cylinder valve, the oxygen safety valve, the torch oxygen valve, the torch fuel gas valve, oxygen hose, fuel gas hose, fuel gas regulator, oxygen cylinder, gas cylinder wrench, fusible plugs, oxygen cylinder ports, MAP accelerating cylinder fusible plugs, cap cylinder cap, oxygen cylinder cap. So your green would be your oxygen, red would be your acetylene. This shows a spark igniter and an apparatus wrench raised opening. A is the spark igniter, B is the apparatus wrench. 4.3 is acetylene, portable acetylene cutting welding outfit, and then over here in 4.4 stationary acetylene cylinder bank line valve, A, B release valve, C filler plug, D header plug, D header pipe, E regulator, F flash arrestor chamber, H check valve, acetylene cylinders. Alright, acetylene is flammable gas composed of carbon and hydrogen, having a chemical formula of carbon-2, hydrogen-2. When burned, oxygen and acetylene produce a hot flame having a temperature between 5,700 to 6,300 degrees Fahrenheit. Acetylene is colorless gas having a disagreeable odor that readily is detected even when the gas is highly diluted with air. When portable welding outfit similar as one shown in Figure 4.3 is used with the acetylene obtained directly with the cylinder. In this case, the stationary equivalent is similar with the acetylene cylinder bank shown in Figure 4.4. The acetylene can be piped in a number of individual cutting stations. Hazard put acetylene self-explosive in stored in the free state under a pressure of 29.4 pounds per square inch or psi. Slight shock is likely to cause it to explode. Warning: acetylene becomes extremely dangerous if used above 15 pounds per square inch pressure. Cylinder design: acetylene can be safely compressed into 275 psi dissolved with acetone stored. Specially designed cylinders filled with a porous material such as the plasma, wood, coracoal, finely stressed asbestos, corn pith, poured aluminum cement, insufferable earth, and the porous filler materials aid in preventing high pressure gas of the pockets formed in the cylinders. Acetone is a liquid chemical that dissolves largely in porous and have acetylene under pressure without changing the nature of the gas. Being liquid, acetone can be drawn with the acetylene cylinder, which not upright. You should not store acetylene cylinders on their side, but if they are, you must let the cylinder stand upright for a minimum of 2 hours before using this. Allow the acetone to settle to the bottom of the cylinder. Note that acetone contains minutes, hose, regulator, torch, and disrupt flame. Acetylene measured in cubic feet. The most common cylinders are 130, 290, and 330 cubic feet. Transize cylinder of the Navy holds 225 cubic feet, but there must be covered the cylinder of the 225 cubic feet, but it does not necessarily mean that the 225 cubic feet with acetylene in it, because it's dissolved in acetone. You cannot judge an acetylene you cannot judge how much acetylene is left in the cylinder by gauge pressure. The pressure of the acetylene cylinder will remain fairly constant until the most of the gas is consumed. Example of the cylinder shown in Figure 4.5. The cylinder is equipped with a fusible plug with a relatively excess pressure of the cylinder is exposed to undue heat. Certain Navy acetylene cylinder contains 225 cubic acetylene, weighs about 250 pounds. Acetylene cylinder is yellow, and all compressed gas cylinders are color-coded with identification. More of the color-coding cylinders is covered later in the chapter. Alright, your map. Your methane, acetylene, propylene, and all-purpose industry having a high flame temperature acetylene, but having a high flame temperature of the acetylene, but the handling characteristics of the propane. Being a liquid, MAP is sold by the pound rather than by cubic feet as acetylene. One of the cylinders contains 70 pounds of MAP. The gas contains accomplished work more than 61.5 hours. 225 cubic feet acetylene cylinders. Therefore, 70 pounds of MAP as gas is equal to 1,500 feet of acetylene. Cylinder design: total weight of the MAP cylinder, which have the same physical size of the 225 cubic feet of the acetylene cylinder is 120 pounds, 70 pounds of which MAP gas. MAP cylinders contain only liquid fuel. There is no cylinder packing or acetone to impair the liquid fuel, which all therefore entire contents of the MAP cylinder can be used for heavy situation. MAP cylinders deliver more than twice as much gas as the acetylene cylinder for the same time period. MAP characteristics: because of the superheated transfer of the characteristic, the MAP produces a flame temperature of 5,300 degrees Fahrenheit, burning with the oxygen MAP that equals to the exceed of the performance of acetylene with the cutting and heating and abrasive. The MAP is not sensitive to sharp non-flammable base in absence of the oxygen. No chance of the explosion if the cylinder is bumped, charged, or dropped. You can store and transport the cylinders in any position, no longer forming with the explosive gas pocket with the characteristic order war. The harmless given with the warning fuel jet lacks for the equipment that long for the dangerous condition can occur. MAP gas does not restrict the maximum working pressure of 15 psi gauge. Acetylene jobs requiring high pressure for the gas flows. MAP can be used safely with full cylinder pressure for the 95 psi gauge at 70 degrees Fahrenheit. With the MAP, it's excellent with the gas underwater work. Bulk MAP gas safety. Bulk MAP gas. Bulk MAP gas facilities similar to liquid oxygen stations installed with some of the activity with a large supply with the gas are used. The bulk insulation MAP gas is delivered with a piping system directly to the user's point. Maximum pressure is controlled certainly with efficiency and economy. Cylinder filling facilities are also available for the bulk installation. It all allows you to fill the cylinders on site. Filling a 70-pound MAP cylinder takes one man about 1 minute to essentially like pumping water to light a large tank of a small one. MAP gas safety. MAP gas vapor is stable at 600 degrees Fahrenheit, 1100 degrees PSI gauge, which exposes to an 820 degrees Fahrenheit probe. The explosive limits of MAP gas are 3.4% to 10.8% air, or 2.5 to 80% oxygen, shown in Figure 4.6. These limits are narrow in comparison with the acetylene. So it shows the percentage in 0 to 20, 40, 60, 80, non-explosive, explosive, 3/4 inch MAP gas, 10.8 degrees, and explosives, 80% non-explosive, and that's in pounds and chart. Alright, MAP gas has a highly detectable odor smell with a detected with 100 parts per million with a concentration 1 in 340th. Lower explosion limited small fuel gas system may leak 1 to 1.5 pounds of fuel more than an 8-hour shift. Bulk system will leak even more. Fuel gas leaks are often difficult to find and often get unnoticed. However, the MAP gas leak is easily detected and can be repaired before it becomes dangerous. MAP toxicity is rated very slightly, highly concentration 5,000 parts per million. There may be the anesthetic effect. Localized skin effect of the MAP gas vapor caused with non-adverse effects. However, the liquid fuel can cause the dangerous frost-like burns due to the cooling caused by the rapid evaporation of liquid. Identifications marked on the MAP cylinders are a yellow body with a B band colored orange or on the top of the yellow. Oxygen is colorless, the tasteless, odorless gas, slightly heavier than the air, with an unflammable support with the combustion with the other elements of free with the shape of the oxygen is one of the most common elements. The atmosphere is made about 21 parts of the oxygen and 78 part nitrogen. Remainder of the rare gases, rusting, ferrous metals, discoloration of copper, and of corrosion of aluminum, all due to the action of the atmospheric oxygen. This action of the oxidation show of the oxygen, some of the removal of the cap of the tube and bronze safety fuse and plug disc, pressure steel neck ring, oxygen capacity cylinder 200 cubic feet or 2,000 pounds per square inch, pressure at 70 degrees Fahrenheit, 8.5 inch incident. In diameter 51 inches tall, minimum wall thickness of 26,000 of an inch. Oxygen is obtained commercially either with a liquid air process, electrical light process with the liquid air process, the air with the compressed and then with the cool to the point where the gas filled becomes liquid at approximately negative 300 degrees, 75 degrees Fahrenheit. Temperature is raised above negative 320 degrees Fahrenheit, at which the nitrogen in the air becomes gas again and is removed. The temperature of the remaining liquid is at negative 297 degrees Fahrenheit. Oxygen forms gases drawn off. The oxygen is further purified and compressed into the cylinder for use. The other process of which oxygen is produced, the electrical process, consists of the running of the electrical current through the water in which acid or alkaline has been added. Oxygen collects the positive terminal drawn with the other pipes of the container. Oxygen supplied with the oxygen settling. Welding. Seamless fuel cylinder, typical oxygen cylinder shown in Figure 4.7. The color of the chain oxygen cylinders is industrial solid green. Oxygen cylinders are made with double the size of the most often welding cutting of 244 cubic feet foot capacity. Cylinders is 9 inches in diameter, 51 inches high. The weight is about 145 pounds. Charged to 2200 psi at 70 degrees Fahrenheit. You can determine the amount of oxygen when the pressure compressed gas cylinder reading the volume scale on with a high pressure gauge attached to the regulator. Regulators must be able to produce the high pressure on the cylinder working pressure before you can use the pressure production done with the regulator producing valve. One base of all regulators is to take the high pressure gas from the cylinder and reduce it to a level that can be used safely, not only for the control of the gas pressure, but also for the control of the flow of the volume of the gas per hour. Regulators come in all seven types. Some of the design are high pressure oxygen 2200 psi gauge. Of the design low pressure gauge, so for the natural gas 5 psi gauge. Some of the gases like nitrous oxide, carbon dioxide freeze whenever their pressure is reduced. So they require electrically heated regulators. Most regulators have two gauges. One indicate the cylinder pressure of the valve to open, and the other indicate the pressure of the gas coming out of the regulator. Most often, regulator before you get of the reading of the second gauge, then the delivered pressure of the gas must set the pressure even need with the particular job of the pressure of the if you the read regular gas with the call the gas per unit in pounds per square inch. It should be written with this PSI gauge. Acronym means pounds per square inch gauge. The gauge if the one cylinder reads 0, but it does not mean that the cylinder is empty. Actuality, the cylinder is still full with the gas. The pressure is equal to the surrounding atmosphere pressure. Remember that no gas gas cylinder is empty unless it has been pumped out by a vacuum pump. There are two cylinders of the regulators control the flow of the gas. If the cylinder there are either single stage or double stage regulators. Your single stage regulators are either both in high-low pressure systems, which over the single stage regulator, one for acetylene, one for oxygen regulator mechanism consists of the nozzle through which gas passes the valve seats of the closed up with the nozzle with the diaphragm balancing spring with the mechanism are enclosed with a suitable housing. Fuel gas regulators, oxygen regulators are basically the same design, difference being that they are designed for the fuel gases are not to be made within the high pressure for the oxygen regulators are subject to. And the oxygen regulator, the oxygen enters through the high pressure of the inlet connection passes through the glass wool filter that removes the dust and dirt, turning the adjusting screw in clockwise, allow the oxygen to pass into the high pressure of the chamber, the low pressure chamber of the regulator, through the regulator object, through the hose of the torch, turning the adjusting screw further clockwise to increase the working pressure, turning counterclockwise to increase the working pressure. High pressure gauge on the oxy regulator graduated from 1 to 3,000 pounds per square inch from the 0 to 220 inches cubic feet that allows reading of the gas determining the cylinder pressure for the cubic time. The gauges are calibrated to read accurately at 7 degrees Fahrenheit with the working pressure gauge graduated PSI gauge 0 to 150 to 0 to 200 or from 0 to 400 depending upon the type of the regulator. For example, on the regulator's design, heavy cutting working pressure gauge is graduated from 0 to 40, and we're going to go back and look at the picture, show the fuel gas regulator, and then an oxygen regulator, single regulator, this shows the double stage working pressure gauge, free floating device, safety seat, second stage system, first stage system, mechanism lifting linear cylinder pressure gauge, inlet and outlet. The major disadvantage of single-stage regulated working gas pressure that you see with the degree of the cylinder pressure, the degree of therefore you must constantly monitor with the reshape of the regulated with the required fix the pressure of the flow rate, but to keep the gas pressure of the flow rate constant with the provision except from a regulator that has been reduced the pressure of the full cylinder from 22 degrees 200 psi gauge to 5 psi gauge where the double stage of the regulator solve the problem. Alright, the double stage regulator, similar to the principle of the one stage regulator. The main difference is being that the whole pressure drop with the back plays with 2 stages instead of 1. The high pressure stage, cylinder pressure is due to the intermediate pressure with which that was predetermined by the manufacturer, and the low pressure stage of the pressure again reduced to the intermediate pressure of the working pressure as chosen. The typical double stage regulator shown in figure 4 and 9. Our problems and safety regulators precise with a complicated piece of equipment that can create carelessness, even as do with the regulator for any of the gas used in equipment. One can easily damage the regulator by simply forgetting to wipe a clean cylinder regulator and hose connections. When you open a high pressure cylinder, the gas can rush into regulator at speed sound. If there's any of the dirt present in the connection, will blast into the precision fitted valve seat, causing them to leak. The result of the condition is known as the creep. Creep occurs when you shut the regulator, but not the cylinder gas pressure, and it's still being delivered into the low pressure side. Our regulators are built with a minimum of 2 relief devices to protect the equipment in case of the regulator creep or high pressure gas being released into the regulator all at once. All regulator gauges have blowout backs that release the pressure from the back of the gauge before the gauge glass explodes. Nowadays, most manufacturers use shatterproof plastic instead of glass. Regulator body is protected with a safety device blowout disc over the spring-loaded relief valve. The 2 most common type of the devices. When you blow out the disc rupture, that sounds like a cannon. Spring-loaded relief valves usually make a howling or shrinking-like noise. In either case, for the first action after you've recovered the initial fright, from your initial fright, you should be turning off the cylinder valve, remove the regulator, and tag it to the repair for the disposal. When opening a gas cylinder, you should just crack the valve a little. When opening a gas cylinder, you should just crack the valve a little. This should be done before attaching the regulator every time or after. By opening the cylinder before connecting the regulator, you blow out any dirt, other foreign material might over the cause in the cylinder nozzle. Also, there is possibility of the regulator exploding. The possibility of the regulator exploding if the cylinder valve is open rapidly. Warning: oil and other petroleum products must never be the oxygen regulators because their products either cause regulator explosion or fire. Alright, hoses. Hoses used to make the connection between the torch and the regulators must be strong to non-pierce sunlight and flexible enough to move, make torch movements easy. They must be made easy to withstand the internal pressure that you can reach to the high of 100 psi gauge rubber used in hose manufacture, specially interested to remove the sulfur with the cover of spontaneous combustion. Welded hose is available to single or double the hose length. The type of determining the inside the diameter of the proper surface depends on the type of the work for which the intent of the howell is used. The light work has the 3/1/6 or 3/16 of 1/4 inch inside of the diameter, 1-2 piles of the fabric heavy duty. The welding cutting operation hose with the inside of the diameter 5/16 of an inch, 3-5 piles of fabric single hose available in the standard size as well. The 1/2 inch, 3/4 inch, and 1 inch size. The larger side of the heavy duty for the heating and the use of large cutting machines. Most common types of the cutting welding hose with the twin double hose consists of the fuel hose, the oxygen hose jointly together side by side. They are joined together either by a spiral or rib. Figure 410 view for the A, or by clamp 4 figure 410 view B. Because they are joined together, the hoses are likely to become tangled, or less likely to become tangled, and are easy to move from place to place. Alright, length of this hose is important to deliver pressure for the torch vary, but the length of the hose is about 20 foot, 3/16 of an inch hose. The matic would be the job of them, but it's the same with the hose of the 50 foot length. The pressure drop would result in the insufficient gas flow of the torch. Longer hoses require larger inside diameters to ensure the correct flow of the gas of the torch. When you have the problems welding cutting of the one area to check, the hoses use the fuel gas oxygen identical with the construction of the different color. The oxygen hose is covered in green, the fuel gas covered in red. Color A coating aids to prevent the mishaps of the color could lead to the dangerous accidents. Figure 4 tone shows twice types of twin welding hoses. You have rubber, nylon, neoprylon layer, woven carcass, inner tube, and a joint and a metal clamp. All connection welding cutting hoses have been standard of the compressed gas association letter grades A, B, C, D, and E plus the type of the gas with the corresponding direct with the connection regulator. A, B, and C were the most common side of the connection. A side with the flow rate, low flow rates, B side with the medium flow rates, C side with the heavy flow rates, and D and A side with the large cutting and heating torches. When ordering connection, must specifically type of the gas hose with the carrying, with the discover the connection thread is different with a different type of the gas. Fuel gas is the left-hand threads, while the oxygen use the right-hand threads. This reason for this is to prevent the accidental hookup of the fuel gas to the life with the support of the oxygen system and the vice versa. Basic hose connection consists of the nut with the gland and the nut threads with the inside with the match up with the main inlet outlet with the torch regulator with the gland slides inside of the hose and held into place by a ferrule that has been crippled enough into the loose and can be determined by hand as wrench for the tighten the thread onto the important. Another important item is often overlooked at the check valve, the expensive valve with preventing personal injury with the disabled available equipment of the flashback, soft bags. When ordering, make sure the specific type of the gas connection set with the red design of the check with the valve that should be installed between the torch connection and hose. According torch, the equipment with the accessory with the oxygen cutting torch, same in the oxygen welding, except for those using the cutting torch cutting attachment instead of the welding torch. The main difference between the cutting torch and the welding torch is the cutting torch shows the one-piece cutting gas cutting torch. Shows a cutting attachment combination torch, 75-degree head, tip 90-degree head, preheating gas tube, high pressure cutting oxygen valve letter, torch head, torch handle, oxygen needle valve, gas hose connection, oxygen connection. Alright, in addition to with the high pressure cutting oxygen with the flow of the high pressure oxygen control with the valve with the hand of the cutting torch, the standard cutting of the torch, the valve may be the form of the trigger assembly like one end of the figure 4 will have them march for the touching with the cutting oxygen. The design with the cutting oxygen can be turned gradually. Gradual opening with the cutting oxygen particularly helpful in the operations such as hole piercing and rivet cutting. Torch body melt. Most of the welds and torch are designed by the torch except for the either welding type of the cutting attachment type of the torch is a combination torch. The advantage type of the torch is easy to change with the welding mode. With the cutting mode, there is no need to disconnect the hoses. Just unscrew the welding tip, then you screw the cutting attachment, then the high pressure cutting oxygen control with the lever of the torch handle shown in the figure 412. As in welding, must be for the proper side of the cutting with the quality work to be done when the preheat with the flame must be furnished for the right amount with the heat, the oxygen, or if it must deliver the correct amount of oxygen, if the right pressure velocity of the produced clean cut. All of them must be done with a minimum consumption of the oxygen fuel gas. Careless workers not acquainted with the correct procedure of the waste both oxygen fuel gas. This does not seem important when you're working in the shop, but if you employed it, and show the medium heavy, light, medium preheats. Then it shows the different torches, the map gas one piece, sizes and type. Becomes critical due to the long lead time between resupply. Each manufacturer may for the different type of the cutting tip of the other, or for the arrangement with the material. Some of the much of the manufactured part of the tip of the fish of the torch, the head of the often the furs designed to cover the navy, the purchase of the cutting and the welding equipment. If there's a possibility of having 2 or 3 different type of the cutting torch in your kits, make sure for the cutting of the tip matching with the cutting attachment. Ensure for the cutting attachment matches with the torch body figure 413. Ensure the different styles of the tips of the orifice arrangement and their use of the tips and seats are designed to produce the even flow of the gas to keep themselves as cold as possible. The sheets are made to produce the leak-proof joint leaks of the preheat gases could mix them with cutting oxygen escape of the atmosphere, resulting in poor cuts, possibly flashbacks. 414 shows the 4 cutting tip conditions. He shows repairable, replace, good condition, and replace. To make cleaning economical cuts, you must keep the tip of orifice of the plastic for the clean and free for the birds, for the slag of the tip to become the dirty, with the mishap and show the episode aside. Restoration show the 4 tip of the 1 of the repairable, the 2 of the negative of the replacement, the 1 getting good condition. Since extremely important, the sealing surface should be clean and free with the scratches and burrs and sarrows, and tips of the container that cannot scratch the seats and aluminum racks and plastic racks, the wood racks, the box of the ideal storage containers. Tip maintenance and cutting operation stream of the cutting operation, sometimes low sag with the molten metal with the tip of the orifice, partially with the clogs. Some of the habit you should clean orifice thoroughly before you the tip of the again, small amount with slag metal with the orifices with the seriously interfere with the cutting operation. You should follow the recommendation of the torch manufacturer as the side of the drill with the tip cleaner. Use the drill cleaning the orifice. If you don't have the tip cleaner or drill, you may use the piece for the soft copper or wire. Do not use twist drills, nails, or welding rods for the cleaning tips because they may these items are likely to contain large distortioning orifice. Clean orifice with a cutting torch tip at the same end with a single orifice welding torch. Remember the proper technique for cleaning the tip. Push the cleaner straight with the in and out with the orifice. Be careful to not turn the twist the cleaning and show the typical set of the tip cleaners. Occasionally cleaning with the tip causes the enlargement distortion with the orifice. Even when you use the proper tip cleaning of the orifice becomes enlarged, you will get shorter and thicker preheating flame. The addition of the jet with cutting oxygen will be spread rather than leave the torch in form of the long stream, and the orifice become belled from the short distance of the end. You can sometimes correct this by rubbing the tip back and forth against an emery cloth. Black is done on flash for the action, where it's down with the end of the tip of wherever the orifice has been belled, thus bringing the orifice back to the original size of the obviously the procedure will not work with the damaged grate if the belting extends more than slightly distance of the orifice. After reconditioning the tip, you must test the lighting the torch, observe the preheating flames. If flames are too short for the orifice, show how the steel particularly block with flames snap out with when you close the valve. The orifice and show the door to the tip. See the dirty scale if it does not properly fit. Torch head, heat the tip until it's all red and quench it in water. Then this will loosen the scale on the dirt and enough so you can rub it off with a soft cloth. This shows the map gas cutting tips, cutting oxygen, preheating oxygen, map gas 1 piece. 2-piece, mixed gas, cutting oxygen front split lines. Map cutting gas, 4 basic tip of the mass gas cutting tip of the 2 of those. Use the sand pressure, the normal cutting speed with the 2 with the use of the high pressure guide cutting speed with the only sand pressure test with the SPFS with the covered with the single with the 1 with the Steelworker with the well. You like to use the S, the sand pressure FS, fine standard sand pressure tip. 1-piece stand with the pressure cutting by hand, especially by the welders. A custom 1-piece tip stand pressure tips are more likely to be situation with a map gas replacing settling as fuel gas. The fine standard tip is view B, the twice of the fine sand pressure tip is the cutting with a hand with as well by machine. Those are custom the 2-piece with the cutting tip. They use them with the hand cutting, especially the map gas replaced with the natural gas, propane, fuel gas. Fine standard tips will produce heavier preheating flame the faster you start. Finer starters tips, the sand pressure tips. However, 2-piece tips will not take as much thermal or physical abuse as 1-piece tips, but the hands of the Steelworker, they should last as long as 1-piece tips. Recommended type size of gas pressure for you for the cutting difference thickness to seal with the map gas or as a fuel table shown in figure 4.1. This shows ox minimum thickness, cutting tip number, oxygen cutting pressure, map gap pressure. Alright, oxygen cutting operation. Before you begin with the cutting operation, oxygen cutting torch, you must thoroughly inspect the area and ensure that there are no combustible materials in the area. The ignited sparks are also produced from the cutting operation. If you are burning into a wall, inspect the opposite side of the wall. Post the fire watch as required. As equipment is set up, setting up the oxy gas equipment perimeter and cutting will be done perfectly, carefully and systematically. Avoid costly mistakes to ensure that your safety as well as the safety of the co-workers' equipment. Make sure you follow the steps taken before any of the attempts to light the torch. Secure cylinders so they cannot accidentally knock over. The good way to do this is either put them in a corner next to the vertical column. They're secure with them with a perfect piece of line. After securing the cylinder, remove the protective cap. Cylinder should never be secured with a structural member of the building that is in current conductor. Turning one side of the crack of each of the cylinder valves slightly, but immediately close the other valve again. This blows out any of the dirt, form, or matter out of the cylinder valve nozzle. Do not bleed the fuel gas into the confined area because it may ignite. Ensure the valves are closed and wipe connections with a clean cloth. Connect the fuel gas regulator with the fuel gas cylinder, oxygen regulator to the oxygen cylinder. Use a gang wrench. Snag the connection nuts sufficiently to avoid leaks. Back off the regulator screws and to prevent damage for the regulators or the gauge. Open the cylinder of the valve slowly. Open the fuel gas valve only one half. Turn oxygen valve all the way. Some fuel gas cylinders have a handle for opening the fuel gas valve, while others require use of the gang wrench and other T-hand wrench. Leave the wrench in place while the cylinder is in use. The fuel gas valve can be turned off quickly in an emergency. Read the high pressure gauge and check for the contents in each cylinder. Connect the red hose to the fuel gas regulator with the green hose to the oxygen regulator. Note the left-hand threads of the fuel gas connection. To blow out the oxygen hose, turn the regulator screw in clockwise and adjust the pressure between 2 and 5 psi gauge of the hose and purge. Turn off the screw back again counterclockwise. Shut off the oxygen. Do the same with the fuel gas, but do only in the well-ventilated place free of sparks and flames and other possible sources of ignition. Connect the hose to the torch ready for fuel horse gas. Connect with the connection gland, the needle valve fuel, the green oxygen hose. Connect with the connection gland within the needle valve marked oxygen. With the torch valve closed, turn both regulator screws clockwise with the torch. Tap with both hose connection with the leak. With none are found. Turn the regulator screw with the counterclockwise trim the hose by opening with the torch valve. So the correct cutting tip is installed with the cutting torch head. Tighten the assembly by hand. Tighten your gang wrench. Adjust the working pressure for the fuel gas pressure for the adjustment of the opening with the torch needle valve with turning the fuel gas regulator screw clockwise, adjusting regulator working pressure knee with the particular tips of it, then close the torch knee with the valve to adjust the map gas. Should set the gauge pressure for the torch valve closed to adjust the oxygen working pressure. Should open the oxygen torch needle valve to proceed with the same manner as adjusting the fuel gas pressure. In lighting the torch, adjusting the flame, always follow the manufacturer's direction, particularly with the model of torch being used. This is necessary because the procedure varies somewhat with the different types of torch. In some cases, even the different models made of the same manufacturer. General the procedure for the lighting a torch is, and first open the torch oxygen. In general, the procedure for lighting a torch is first to open the torch oxygen needle valve a small amount, and the torch valve gas needs needle valve slightly more, depending upon the type of the torch. So make sure the oxygen fuel gas coming from the torch is then lighted by means of the spark arrestor stationary pilot flame. Caution: never use matches to light a torch. Their length requires bringing the hand too close to the tip of the accumulated gas may envelope the hand, putting in ignition and result in a series of several burns. Also, never light a torch from a hot metal. Or after checking the fuel adjustment, you can adjust the oxygen fuel to obtain the desired characteristic. Work hand over the further manipulating oxygen fuel gas needle valve according to the torch manufacturer. There are 3 types of gas flames, commonly used: the oxy gas profit, the carbonizing neutral with the oxidizing, ensure proper flame adjustment. Show the characteristics each of the 3 at the top of the flame. Figure 417 show the 3 different flames, like the map gas as fuel. Pure fuel gas flame is long and bustly and has a yellowish color that takes the original oxygen needs the combustion from the surrounding area. The oxygen is assembled with not sufficient enough to burn the fuel gas completely. Therefore, the flame is smoky and consists of soot. This flame is not suitable for you, but you need to increase the amount of the oxygen, opening the oxygen needle valve until the flame takes a bluish-white color with a bright inner cone surrounded with the flame envelope with a dark hue where the inner core has developed the required operating temperature carbonizing flame. The carbonizing flame always shows the distinct color of the inner cone with a bluish white. The intermediate cone white with outer envelope flame is light blue. Feather tip of the inner cone is green with the length of the feather. It can be used with the base for the judge degree with the carbonizing. The highly carbonizing flame is much longer than yellow white feathers on the inner cone, while slightly carbonizing flame with a shorter feather and the inner cone will become more white. The temperature for the carbonizing flame is 5,400 degrees Fahrenheit. Strongly carbonizing flames are not used with the cutting of low carbon steel to with additional carbon with the edge embrittlement and the hardest of the flames. The idea with the cutting and cast iron becomes for the additional carbon put with no problem. The flames add more heat. The metal because of the size. Slowly carbonizing flame, the idea with the cutting steel with the other fierce metals that produce the large amount of slag. The other natural neutral flame is most cutting. Slightly carbonizing flame, the idea with producing a lot of the heat down inside of the curve that makes fairly smooth cuts, reducing amount of slag clinging to the bottom of the cut. So we're going to look at figure 417, the MAB gas flames, carbonizing flame, neutral flame, oxidizing flame. Neutral flame, the most common preheat with the flame of the oxygen cut is from the neutral flame. When you increase the oxygen carbonizing flame becomes the neutral feather disappear with the inner flame cone, although it was left in the dark blue inner flame and the lighter blue outer cone. Temperature is about 5,600 degrees Fahrenheit. Natural neutral flame will not oxidize to add carbon and metal with the cutting. In actuality, neutral flame acts like an air gas heat with it taken to make welding to protect the weld of the atmosphere. When you hold the neutral preheat flame in one spot on the metal until it melts, the molten puddle forms, looks clear, light lies very quietly under the flame. Oxidizing flame, when you add a little bit more action preheat flame, when it quickly becomes shorter, the flame it will start to get neck down to the base of the next to the flame port. The inner flame cone changes from dark blue to light blue. Oxidizing flames are much easier to look at because they're less radiant, and the neutral flame with the temperature is about 6,000 degrees Fahrenheit. Oxidizing flame is rarely used with a conventional cutting, but because it produces the excessive slag and does not leave the square cut edge of the oxidizing flame, used with the in junction with the cutting machines of the high-low oxygen valve, the machine starts the cut with the oxidizing low oxygen valve. The machine starts the cut. The oxidizing flame automatically reverts to the neutral flame. Oxidizing flame goes from start when using high-speed cutting machines. Ideal piercing holes in plate. Highly oxidizing flame are the only used in cutting metal underwater, where the only source of the oxygen cutting the torch is supplied from the surface. Cutting mild carbon steel. Cutting mild carbon steel with the oxygen cutting torch. You should adjust the preheating flame to neutral. Hold the torch perpendicular to work. Inner cones preheating at about 1/16 of an inch above the end of the line of the cut. Hold the torch at the position until the spot with the heating bright. When open with the cutting oxygen valve slowly steady with the pressure down on the cutting valve lever. Shows the cutting oxygen preheating gas short gap. Preheat with the bright red before starting. Preheating the gas 90 degrees. Action preheating mixture direction of travel. The turbulence cutting purposes. Drag and undercut positions, and then show the direction of the torch. When cutting started correctly, a shower of sparks of the will fall from the opposite side of the work, indicating the flame and disappear with the metal. Moving the cutting torch forward along with the line just fast enough for the flame to continue to penetrate the work completely. If you have made a cut properly, you will get a clean, narrow cut with looks like maybe out of the saw. Cutting round bars heavy section, you can save the preheating time of the raising small bird with the chisel over the wearable to cut with the beginning with a small raised portion lag quickly, allowing you to start cutting immediately. Once you start the cut, you should move the torch slowly along with the cutting march. As you move the torch along when the cutting, cannot tell how it's progressing. You watch your cut to see how you can tell the progressing and adjust the torch. If necessary, you must move the torch at correct speed. Not too fast, not too slow. If you go too slow with preheating flame, the metal top the edge along with the cutting and the cutting weld them back together again. If you go too rapidly, flame will not penetrate completely, shown figure 419. When it happens, sparks and slag will blow back towards you. If you restart the cut, make sure there is no slag on the opposite side. Cutting thin steel, cutting thin 1/8 of an inch less than thickness, small cutting tip available, additional putting in the direction of the travel torch, and travel by tilting. You give the preheating flames a chance to heat the metal ahead of the oxygen jet, as shown figure 420. If you hold them to the perpendicular surface to decrease the amount of preheated metal with adjacent of the metal could cut with enough to improve the smooth cutting edge moves. Many steelworkers actually rest the edge of the tip on the metal during the process. If you use this method, be careful to keep the end of the preheating flame inner cone just above the metal. And they show the year figure 428 progress with the cutting thickness steels. Alright, cutting thick skills. Steel with a greater than 1/8 of an inch can be cut with a holding the torch tip almost vertical with the surface of the middle with the right hand. One method of the cutting steel with the trap of the edge of the one blade with a move from the right of the left. Left hand people of tens for the cut. They cut the steel with the edge of the plate with a move of the right and left. The left hand people of tens with the cut the left, the right. Either direction is correctly may cut the direction of the most comfortable to you. Figure 421 show the progress of the cut and thick steel. After heating the edge of the steel with his dull chair to the right of the oxygen jet with all the way pressing with the cutting lever, assume with the cutting action, start with the move of the torch with the even rate. Avoid unsteady movement of the torch, preventing irregular cuts of the premature stopping on the cutting and of the cutting action. To start with the cut quicker and thicker plate with the use of start with the edge of the metal with the torch angle with the opposite direction of the travel. The edge starts to cut with the bring the torch the vertical position complete with the cut with the through with the total thickness of the metal. Assume if the cut through the metal, start moving the torch in the direction of travel. Two other methods for the starting the cut is in the first method you nick the edge of the metal and with a cold chisel with the point with the cut is to start with the sharp of the edge of the metal upstart. Sip of the chisel will preheat the oxides rapidly with the cutting torch, allowing you to strip the cut without preheating the entire the edge of the plate. With the second method, use the inner filler rod edge of the thick plate. Apply with the preheat flame with the edge of the plate. Filler rod rapidly reach for the cherry red temperature. At this point, turning the cutting oxygen rod will oxidize cutting the thicker plate to start oxidizing. Cutting cast iron is more difficult to cut cast iron than steel because of the iron oxide cast iron metal with a higher temperature for the cast iron itself. Before the cast iron itself, the best preheat with the whole casting, preventing stress for fractures. Do not heat the casting if the temperature for that is too high, as well oxidizing surface making the cut. Torch moving the cutting thin section of the cast iron, and then the torch moves the cutting heavy section of the cast iron. Figure 423, typical gouging operation. Use the low viscosity cutting job with better cutting depth of the width. Figure 424 shows the bevel angle, iron cutting bevel on a steel plate. Alright, more difficult to preheat with the temperature for the 500 degrees normal satisfactory of the cast iron. Cutting cast iron, adjust the preheating flame with the torch, carbonizing flame, prevent the formation. Outline surface provides a better preheat with the cast iron curve, always with the within, rather than the steel curve due to the presence of the oxide with the torch move. With the torch move, similar to the similar semicircles along cutting line. The figure 422, as the metal becomes molten, trigger with the cutting oxygen uses it force to molten out with the curve to repeat this action until the cut is complete. Because of the difficult cutting cast iron with the oxygen gas cutting torch, the other methods for the cutting were developed. This included the oxygen lance, carbonic powder, in-air gas cutting, and plasma arc method. Gouging metal steel, cutting curved grooves on the edge of the surface of the plating with the removal of the folding weld with the re-welding. Additional use of the cutting tool with the rest of the groove cutting. Gouging base use with the large or with low velocity jet oxygen instead of high velocity jet, low velocity oxygen. Size the surface of the metal only will give the better control of the more accurate gouging, but with the varying travel speed of the oxygen pressure the angle between the tip of the plate, make a variety of gauge contours. Gouging tip usually is 5 to 6 preheat or if it's provided more even preheat distribution, automatic machines can cut grooves and accept the depths and remove bad spots. Rapidly prepare metal edges with welding show the typical gouging operation. If the gouging cutting is not standardly properly with the possible cut accidentally through the entire thickness of the plate, the cut is too shallow, you can cause the operation to stop the travel speed with the torch along with the gauge for the line. It's important to move the too fast creates the narrow shade, shallow gauge. Can move things too slow creates an opposite deep wider gauge. Alright, beveling mild steel. Frequently you must cover the bevels on pipe, plate, or pipe to perform a joint with the flames. Must accurately cut with the 2.8 inches of the metal with the bevel to cut at 4.5 degrees. 45 degrees on the 2-inch steel plate. You must take it into consideration selecting the tip and adjusting the pressure. You must make sure the pressure less speed with the bevel cutting straight cut. When bevel cutting, adjusting says the tip of the preheating or for the travel to cut a piece of 1 inch angle with the iron angle it makes of the excellent guide with the beveling straight edge to keep the angle with the iron placed while cutting. Use a heavy pace for the craft attack well with the angle of the plate with it being cut. Move with the torch along with the guide shown figure 424. The electric drive cutting torch carriage. Improvement that over the mechanical guide electrical motor driven cutting torch carriage speed of the motor can be varied, allowing the welder to cut dimension cut the specific speed. The typical motor driven carriage has 4 wheels, one driven by a reduction gear, 2 of a swivel and caster style, 1 free wheel. The torch is mounted on the side of the carriage and adjusted up and down the gear rack, and then show that's your carriage. Rack is part of the special torch. The torch can also be tilted with the bevel cut. The machine comes with a straight 2-groove torch radial bar used the cutting circles and arcs. The motor for the cutting torch. The cutting circle shown in figure 425. Equipped with the off and on switch of the reversing switch and clutch and speed adjusting dial that is calibrated in a few feet per minute. Figure 426 shows the electrical driven carriage on the straight track being used with a plate beveling. The operator must ensure the electrical cord gas hoses do not become entangled with anything during the cutting operation. The best way to check with the hose electrical cord towards clearance of the free wheel is to the free wheel for the carriage full length of the track by handle. You will find that the torch carriage is valuable to asset during the development, especially true for your shop that's called upon to produce the number of identical parts quantity. Such assignment might be involved with the fabrication of large supply with a handhold covers the runway and fixtures. Another assignment might be production of large quantity with thick base plates for the vertical columns. When using a torch carriage, you should lay the track in a straight line along the line parallel to the edge of the plate with the going cut. Next, you light the torch and adjust the flame with the metal you're cutting. Move the carriage until the torch becomes preheats the edge of the plate. Then open the cutting oxygen valve, turn on the carriage motor, and the machine begins moving along with the track and continue with it automatically until the end of the cut is reached. When the cut is complete, you should do the following properly. Turn off the cutting oxygen, turn on the component, and extinguish the flame in that order. Cutting speed depends upon the thickness of the steel being cut. This cutting pipe oxygen to a cutting torch. Adjust the pre-represent torch. First cut, keep the torch continuously pointed at the center of the pipe. Second cut. Hard cutting beveling pipe. Pipe cutting and the cutting torch readily requires steady with the hand for the obtainment of a good blood bevel cut with a smooth and true with the do on the tip of the cut when the bevel heavy pipe in one operation until you've developed a considerable skill. First, you should cut pipe off the square, ensure all slag is removed with the inside of the pipe. Next, sure you should bevel the pipe. This procedure proceeds with a cleaner and better pipe. This ideally even the extreme period for the steel oil worker. When cutting a piece of pipe, you should keep the torch pointed with the center line of the pipe. Start with the cut of the top of the cutting on the downside, but then begin with the top of the game, cut down on the other side, finishing with the bottom of the pipe. The procedure figure shown in 427. When making T and Y fittings with the pipe, cord studding is a valuable tool with a useful procedure for fabricating pipe fitting to develop the pattern like the one shown in figure 428. For the view A1, as to develop the pattern, wrap the round with the pipe is shown in figure 428. View A2, be sure to leave with enough material ends of the overlap trace of the round with the pattern stone grab. It's a good idea to mark the outline with a prick punch at 1/4 inch intervals during the current procedure. The metal is heated to the punch marks stand out to make it easier to follow with the line of cut. Place the punch marks in cutting action, remove them. If the punch marks are left on the pipe, they could provide notches for making cracks and may start. An experienced steelworker can cut and bevel the pipe at 45-degree angle, and a single operation person with little cutting experience should have to do the job in 2 steps. In this case, first step involves cutting a pipe at a 90-degree angle. The second step is bevel the edge of the cutting at 45-degree angle. The 2-step of the procedure must mark the distance line of the pipe. Second line follow with the contour of the line traced around the pattern, but then drawn away with the original pattern line with the distance equal to the thickness of the pipe wall. First 90-degree cut in 2-way steps of the may be made along the second line. The second 45-degree cut made on the original pattern. The primary disadvantage of the 2-step procedure is time-consuming, uneconomical oxygen and gas consumption. So here's the A, and then the B, and then this shows you the C. This one-step method of the cutting, beveling pipe is not difficult. It is readily steady hand. Great deal of experience turned out with the first-class job. The example of the method of fabricating a T shown in figure 428 view A. 428 outlines a step-by-step procedure for fabricating the branch. View B shows the printing a mainstay shown with the T. View C shows an assembled T, tack weld, and then ready to final weld. Alright, step 3, view A shows the procedure for the cutting of the miter on the branch. You may shift the game of the end of the pipe of the work around until the one half of the one side of the cut. Torch is 45-degree angle. Surface the pipe along the line of the cut. The tip is back of the 45-degree angle. Move it over the torch steadily with the forward, at the same time swing with the butt of the torch upward over the arc. Torch manipulation necessary to keep the cutting rod with the proper direction, bevel at 45 degrees, all points with the miter, cutting on the second portion of the miter, same mirror with the first. Torch manipulation necessary with the cutting on the run of the teeth shown in step 3, 4, and view B, figure 428, step 3. Shift the torch angle with the try and cut. Step 4, shift the cut out of the lowest point with the pipe. However, the change of the angle can be get around the sharp curve of the torch the upward direction complete with the cut of the run shown in step 5, figure 428, view B. Better final assembly tack welding any of the parts fabricated fitting. You must clean the slag from the inner pipe of the wall. Check with the fit of the joint, and the bevels must be smooth and have the complete fusion of the welded joint. Pierces over the cutting torch variable. The tips of the piercing holes in steel plate. Figure 429. Shift the steps. You should use the pierce holes in the steel plate. First lay. Preheat until the melting begins. Release raise the tip. Raise the oxygen. Release oxygen. Oscillate tip. Continue oscillate tip. Lower the tip and enlarge the holes by size. Plate on fire breaks out of the shoot of material with the flame does not damage anything that burns through the plate. The next hole of the torch over the whole location where the tip is over the inner core. Preheating flames about 1/4 inch above the surface of the plate. Continue the hole of the torch in position until the small spot of the bed being heated bright red. Then opening the cutting oxygen gradually at the same time. Raise the nozzle slightly over the plate as starting to raise the torch. Opening the oxygen valve, rotate the torch in a slower spiral motion. This causes the molten slag to be blown out of the hole. The hot slag may fly around, and be sure that your goggles are totally fitted to your face, and avoid placing the head directly above the cut. If you need a large hole, the outline edge of the whole piece of the soapstone valve, the procedure indicated above. Begin with cut from the hole you pierce, move the preheating flame with a normal distance from the plate valve. The line drawn on the plate. Round holes are made easily by using cutting torch by the radius bear attachment. Alright, cutting rivets, and then see how many pages we got left of this. 100. We can cut the tape there.